kept alive, the most important raw material on Earth, the most important too for the survival of mankind. One or other of the plants here might contain the very genes which could help to broaden the all too narrow basis on which the food supplies of the world's exploding population depend. 85% of all agriculture is today based on less than 30 food plants. It could also quite well be that the last remaining specimens of some wild plant, which might be important for the future, are at this very moment being crushed by wheels, ending up in a cooking pot, or being eaten by a horse. The juggernauts on our roads, sprawling cities, certain industries, and artificial man-made substances, we've all known for a long time what a threat they can be to nature. The emissions from this steel works are endangering the flora along the Mississippi. This was all we were allowed to film. The factory security guards chased the camera team away with threats of violence, and this was in the land of the free. This, according to Vavilov, is where the sunflower has its natural origins. It's above all the plant breeders who are busily at work trying to safeguard plant genetic reserves for the future. These plant breeders are at the International Center for the Improvement of Maize and Wheat in Mexico, one of the centers from which the Green Revolution was launched. Thousands of strains of cereals are collected and preserved here. Another institute in the Philippines specializes purely in rice, and one in Peru in potatoes. Gene banks in the service of world food. And there are also more and more national gene banks. In Western Europe, the largest is in Brunswick, in the Federal Republic of Germany. International agreements are designed to ensure that every country in the world, without any political restrictions, can draw on the gene banks at any time. What looks like a bunker here is a gene bank of a very special kind. It's the United States National Seed Storage Laboratory at Fort Collins in Colorado. Every day, new deliveries of seeds arrive here in sacks, packages and envelopes from all parts of the world. They come mainly from international, national and private research and seed breeding establishments. There are already about 100,000 plant species, subspecies and strains registered in the computer. The newly arrived seeds are counted and weighed and tested in the laboratory. A whole series of further criteria govern their suitability for storage and ability to reproduce later on. In the germination test, a specific number of seeds is laid between sheets of damp blotting paper, put into the growth chamber to germinate, and the seedlings are then counted. The norm is that 95% of the stored seeds must be germinable and remain so. Germination in the growth chamber is tested in 2 phases, because a delayed start of germination is an indication of diminishing germination capacity. One of the Gene Reserve Bank's problems is that it receives some seeds in such small quantities that not all the necessary tests can be carried out. The probable first parents of the maize plant, for example, gamma grass and teosinte are each represented in Fort Collins by barely a handful of seeds. Seeds to be preserved have to be tested to see how viable the germ tissue is. The seed corn is carefully cut up and put into a bath of tetrazolium. Then the petri dish is placed for a while in the incubation oven. The subsequent examination reveals how much of the tissue is alive. This is clearly recognizable from the red coloration caused by the tetrazolium. The main purpose of the Institute is to keep reserves of genes to maintain genetic resources. Any seeds that can be spared are continually sent out again in very small quantities, but only if those requesting them can't find the material they're looking for in an ordinary seed bank. Once it's established that they're suitable for conservation, the batches of seeds are dried out so that they have a residual moisture of no more than 3 to 5%. Then the aluminium-coated bags are hermetically sealed and placed in the cold storage room. The cold storage rooms already contain countless thousands of samples in a state of hibernation, so to speak. Gene reserves for the future. The ideal storage temperature is about minus 17 degrees Celsius. Refrigeration for the cold storage, heat for the growth chambers. Both are supplied by electrically operated equipment installed in the basement and backed up by standby units. If a gene bank is really to fulfill its long-term purpose, its energy supplies and the machinery must go on functioning for centuries without a breakdown. Several times, irreplaceable genetic material in seed banks has been lost through power failures. In Fort Collins, to make long-term storage less dependent on public utility supplies, they have for some time now been using other methods. In chrome steel containers like these, of the kind used in technologies such as blood plasma extraction, artificial insemination and organ banks, the plant seeds are stored in liquid nitrogen at minus 196 degrees. This method, known as cryopreservation, dispenses with the need to rely on electricity supplies or mechanical systems. The liquid nitrogen comes from a tank behind the building, which only needs to be refilled once a year. Scientists at Fort Collins claim that the problem of temperature shock in putting the seeds into storage and removing them again has already been solved. One of the devisers of the new method is Philip Stanwood.
We believe by using liquid nitrogen that we have three distinct advantages over conventional systems. The first area being the biological advantage. Basically, we can place materials at those temperatures and retrieve them without damage. The advantage is that if we hold it there 1 day, 1 hour, or 1,000 years, it is not significant from a biological standpoint. The second major advantage that we see with liquid nitrogen is that we have much better mechanical reliability of our storage systems. Since most of the liquid nitrogen systems that we use are passive in nature, they do not require external mechanical systems for their maintenance. Therefore, we have much greater stability. We are not dependent on outside resources such as electricity and mechanical devices. By taking these two advantages of the biology and of the mechanical reliability of the